A firm manages a large volume of daily clickstream logs within an Amazon S3 bucket. Data scientists need to query this information using Amazon Athena to evaluate performance trends over the most recent 72-hour period. Company policy requires maintaining the logs in an active state for 30 days before moving them to a cold storage tier. Which architectural approach will optimize Amazon Athena query performance?
Option A, retain the logs in a single S3 bucket without using any partitioning strategy and manually relocate expired files. Option B, employ AWS Lambda to relocate logs into unique S3 buckets and configure S3 lifecycle rules to move objects to S3 Glacier Flexible Retrieval after 30 days. Option C, structure the logs in S3 using date-based prefixes for partitioning and configure S3 lifecycle policies to transition data older than 30 days to S3 Glacier Flexible Retrieval.
Option D. Assign logs for each day to a distinct S3 bucket and apply S3 lifecycle rules to move the buckets to S3 Glacier Flexible Retrieval once they exceed 30 days. This question touches on the concepts of data organization and lifecycle management within cloud storage. It specifically focuses on how data structure affects the efficiency of serverless query engines when dealing with time series data, and how automated policy-based management handles data aging.
I believe the correct answer is option C. Structure the logs in S3 using date-based prefixes for partitioning and configure S3 lifecycle policies to transition data older than 30 days to S3 Glacier Flexible Retrieval. This approach works best because partitioning data allows the query engine to scan only the necessary data rather than the entire dataset. By organizing time series data using date-based prefixes, you enable partition projection, or predicate pushdown, which significantly limits the volume of files. S3 lifecycle policies are the most efficient, cost-effective, and automated way to move older objects to cold storage, like S3 Glacier, without needing complex custom code. Options A, B, and D are less effective. Storing data without partitioning, as suggested in option A, or scattering data across individual buckets, as in option D, is not scalable and hinders query performance. Using AWS Lambda, as mentioned in option B, adds unnecessary overhead and maintenance for a task that S3 lifecycle policies handle natively.
When preparing for your exam, remember that whenever you see a requirement to optimize query performance for large datasets in S3, partitioning is almost always the key. Avoid solutions that require complex external services like Lambda if there is a native, simpler feature like S3 lifecycle rules available. Keep your storage architecture simple and let built-in platform features manage your data aging processes automatically.